Hello everyone, we are back for another exciting episode of staining. Now, for those of you, I'm assuming that you've already watched smear prep, simple staining, and gram staining. It's important because each of these stains builds up off of the last. As we saw with simple staining, we took a heat-fixed smear prep, and then we added some stain to it to look at the bacteria's morphology. For gram staining, we then took a smear prep, a simple stain, and then added a mordant, grams iodine, plus we did something to it. So it's stain plus mordant plus something gets you a test. And we're building off of that this time, because this time we're doing what's known as acid-fast staining, which is a very similar stain. We're going to start with a different stain, carbofulcin this time, and then we are going to move on to do some kind of test to it, in this case acid alcohol, and then we are going to add in a counter stain. So stain, test, counter stain. This is one of the more dangerous stains that we have in the lab because carbofulcin in its base form is carcinogenic. In order for this to work in a timely manner, we are using the chess modification of acid-fast staining, requiring us to use a microwave. Now this is called the hot stain version. This is the Gale-Nielsen procedure that we'll be doing today. And why do we care? Well, let's take a look at some of the bacteria that we have. There's one type of bacteria in our lab that we know for a fact is what's known as gram variable, and that is the members of the genus Mycobacterium. And the reason it's gram variable is because the mycolic acid inside the cell wall makes it incredibly difficult for it to stain through normal means. So in some cases, an older Mycobacterium might mix with gram-positive and gram-negatives, and we need to know exactly how to identify that. For this, the assumption is that you will be following along with your book. That means we are starting, if you are in 2421 for majors, page 60 of Harley's, and if you are in nursing, it's exercise 3.7, page 195 of Leboff and Pierce. A big thing to note about this is that the original acid-fast stain derived by Paul Ehrlich was to really find out one thing. To find out if a bacterium was the white wasting, the king's touch, the master of all of these men of death. We are, of course, talking about Mycobacterium tuberculosis. Now, Mycobacterium tuberculosis is a scourge. It's one of the true scourges of humanity. I will put it up there with things like cholera, which oddly enough is a Vibrio, it's Vibrio cholerae, leprosy, which is also a Mycobacterium, Mycobacterium leprae, and malaria, which is Plasmodium vivax. It's a parasite rather than a bacteria. It is synonymous with humans. It is well known among humans, and it reflects that in its common names. The reason why identifying Mycobacterium tuberculosis is difficult is because it doesn't stain well, it's a mycobacterium, and it's a small bacteria. So the Gale-Nielsen acid-fast staining procedure was first developed by Franz Gale, a German bacteriologist, and another, a Friedrich Nielsen, a German pathologist, in the late 1800s, and the term acid-fast itself was developed also around that time by Paul Ehrlich. How we are going to do this is we are going to have carbofulcin, right here. We're going to have carbofulcin, acid alcohol, which is hydrochloric acid and alcohol, and methylene blue. On these slides, we have here Bacillus megaterium. I'll shift that over. Bacillus megaterium is an acid-fast negative. And Mycobacterium non-chromogenicum, which is an acid-fast positive. As I said before, we are using carbofulsion. Carbofulsion is highly carcinogenic. It also means that we're going to have to heat it up, which makes it even more carcinogenic. We are going to be flipping between a few different things here, between the staining bin, the desktop, and maybe a microwave. If I don't show the microwave, you're just going to have to trust me that I microwaved my slides. So on here we have our heat-fixed smear preps, and we are going to start by adding in our carbofulsion. Now, unlike in the past, what we've done is we've at this point rinsed them. We're actually not going to do that. It's at this point that we will put them on plate, and I'll make our plate off to the side here, and we are going to microwave our slides for 30 seconds. Now here we are on the desktop. This is a simple glass petri dish, and I'm going to put on the petri dish some circles of paper towel. I am then going to take my bottle of DI water, place the rod right there. I am then going to take one of my slides and place it right on top. And we are now going to take this over to the microwave and cook it. And now that we're back, you can see that the slide is more metallic. That's what happens when you heat up carbofulsion. I did leave this in the microwave for a few seconds, about 15 seconds after I opened it up. The microwave inside is inside of a chemical hood, specifically just in case we do have problems. Things like the stain cooking too long, boiling, that type of thing. Now, why do we heat things up? In this case, we heat up the carbofulsion to drive the carbofulsion into the cell itself. If without the heat, the carbofulsion won't stain. But with the heat, it drives it in, and then this stays inside the cell. When you apply acid alcohol to it, and a gram-positive organism, an organism with the mycolic acid, it will not decolorize, but it will for everything else. So we're just going to set this off over to the side. Now let's do the prep again, but for our other slide. This is for the mycobacterium. We're going to take some paper towel, line the bottom, give it a DI water, put our V-rod in, and we're going to bring over our mycobacterium slide, put it right there, and we're going to go put it in the microwave for 30 seconds. Now for the remainder, we're going to be splitting this up into two separate things here. So we are going to start with our bacillus right here, and you could probably hear off in the distance there, that is the mycobacterium finishing. We're going to start with a DI rinse of the slide. Next, we're going to add our acid alcohol. And it will, yep, it's going right over onto our name. That's going to be erased. Same as the decolorization step. It's important that we don't over-decolorize. And now we're going to add in our counterstain, which is methylene blue. And we're going to let that sit for 30 seconds. Okay. Now we're going to rinse again with DI water. And then we're going to go blot it dry with bibulous paper. Now, I have added in to this the methylene blue after we have counterstained. And we are going to rinse it once again with DI water on our Mycobacterium. And we'll take a look at this one compared to the other. And now we're going to blot dry with bibulous paper. And there's our Mycobacterium. And here's our Bacillus megaterium. Now we are going to do one last time. This time we're going to do it on the same slide. Here's our acid-fast positive and our acid-fast negative. Same as before, start with some carbofulsion. Then we are going to put this on a paper towel and the V-rod. DI water. V-rod. Our slide. We're going to go put this in the microwave for 30 seconds. And here we are back with our acid-fast stain. We're going to shift this out of the way and shift back in our staining rack. Put our slide right here. And we're going to take our DI water, and we are going to rinse the slide. Now we're going to add our acid alcohol. Again, only a few seconds. Now you look, it does seem like there's a lot of purple there. Most of that purple is actually from the Sharpie, not the bacteria. Now we're going to wash with water. And counterstain with methylene blue. It's been about 30 seconds, and we're going to rinse. And take a look at these guys under the scope after we blot them dry with bibulous paper. There's our slide. Let's take a look at these guys under the scope. And we are back here on the Leica LASEZ. So let's take a look at our slide. The first one we're going to look at is the Mycobacterium non-chromogenicum. And let's zoom in a bit, do our very basic good microscopy, and peek around a bit. You do see there are some splotches where there's purple left over, which is good to see. There's a little bit of blue as well. That can happen. But let's see if we can find some bacteria near the edge for us to look at that are on their own. There we go. And we're going to zoom in to 40 times. 10 times. And adjust. 40 times. And we're going to shift over a little so I don't crash into the edge of the stage. And now we're going to swing into oil immersion. There we go. Now you can see that most of the cells, which this is a cell here, most of the cells on here are going to be a deep purple. Ah, here we go. Now I did move the stage around a bit so you can see a better look at these purple little cells here. These are your Mycobacterium. They're small little purple rods. Now remember, they're purple, which means they're acid-fast positive, which is to be expected with this genus. And now we're going to see if we can zoom in on some of the Bacillus megaterium. Ten times. 40 times. And we're going to go up to oil immersion next. This one does seem to be a bit more difficult to find the bacteria on. There is fewer bacteria here. See if we can go to a more clustered location. We might have to zoom out and try it again from a different angle. Yeah, we're going to have to try that. Now, the reason why this seems to be taking a bit more difficult swing of things is because I used very little bacteria when making this prep. Here we go. Here's a nice clump. Very nice. Now we're going to go under oil immersion. Here we go. And as you can see, these are bigger blue rods. This is an acid-fast negative organism. To be expected, it's not a mycobacterium.